Chapter 10.1, we're looking at inclination of a line. We're going to find the inclination of a line, find the angle between two lines, and then find the distance between a point and a line. In section 1.3, you learned that the slope of a line is the ratio of the change in y to the change in x. In this section, we're going to look at the slope of a line in terms of the angle of inclination of the line. Every non-horizontal line must intersect the x-axis. The angle formed by such an intersection determines the inclination of the line, and we're going to look at the definition below. The inclination of a non-horizontal line is the positive angle theta that's less than pi, measured counterclockwise from the x-axis to the line. So notice this does not cross the x-axis, that's horizontal. But here, notice we're measuring the positive going counterclockwise from the x-axis. Same thing here, so this is vertical, acute, and obtuse. So the inclination and slope. If a non-vertical line has inclination theta and slope m, then we're going to look at m equals tangent of theta. Note that if the m is positive, slope is positive, greater than or equal to 0, then theta equals just arctangent of m, because theta is between 0 and pi over 2. Then on the other hand, if the slope is less than 0, so if you have a negative slope, then it's going to be theta equals pi plus arctangent of m, because pi over 2 is, or theta is between pi over 2 and pi. So, pi over 2 and pi, just remember that is going to be in quadrant 2 here, right? And so then we need to make sure and add pi to it, because what we're going to see is the angle down here. Okay, arctangent, just remembering arctangent, we're taking a look at the quadrants that it's restricted to is in quadrant 1 and 4. So when you have an angle that goes through this way, we're going to get this angle, right, the negative angle here. And so in order to get the positive angle that we're looking for from the x-axis to here, we have to add pi, right, in order to get this angle here to help us out. So over the first example, to find the inclinations of lines, so find the inclination of x minus y equals 2. And so hopefully you can tell what the slope is here, but you can always solve for it. So let's go ahead and subtract x from both sides. Let's put it in slope-intercept form. Negative y equals negative x plus 2, divide by a negative 1. And so all we really need is that our slope is a positive 1. So we're going to use, so we know that the slope is greater than or equal to 0, so we're going to use tangent of theta equals our slope, right? Tangent of theta equals m, so tangent of theta equals 1 is what we have here. So then we have to remember, what is that? So we're taking the arctangent of 1, and so 1, I hope you remember that that is pi over 4, which is 45 degrees. So it is going to ask you to find it in radians and in degrees for the homework. Letter B, we have 2x plus 3y equals 6. So let's find the slope first. 3y equals negative 2x plus 6. So therefore we find that our slope is negative 2 over 3. And so now we're going to use tangent of theta equals negative 2/3, but remember our slope is less than 0. So what we're going to use is theta is going to be pi plus the arctangent of negative 2/3. So then you plug it in your calculator. So, remember your calculator needs to be in radians. Okay, radians. So you plug it in your calculator, so arctangent of negative 2 over 3, and you will get approximately negative 0.5880. So notice negative, it's going to be down here. So we have to add pi to it, that's why it's here. And then, so round to 4 decimal places. So this is going to be, when you add pi on your calculator, 2.5536 radians. Then you have to convert it to degrees. So remember to convert it to degrees. So if you have radians, in order to convert it, you multiply by 180 over pi. So that's what you're going to do with this 2.5536. Leave your calculator as it is, multiply by 180, and then after that, divide it by pi, and pressing the button pi. And therefore, when you find the answer, that should be 146.3 degrees. So try this example, find the inclination of both of these lines. So trying this out, letter A, you find that the slope is 4 over 5, and so that slope is greater than or equal to 0. So we're going to use tangent of theta equals 4 over 5. So you would find that's approximately 0.6747 or 38.7 degrees. For letter B, you find the slope is -1. And so if you think about that, that is, hopefully you remember that is just here at 3 pi over 4. And we also know it's at negative pi over 4 here, right? So however you remember that, and so you'll have to add pi to it. So if you are in fact taking the arctangent, you find that is negative pi over 4. And then so for applying this formula here, then that's why you have to add pi, right? Because we want this angle here. So the whole reason why we're adding pi is because we want this angle here. So then therefore you get 3 pi over 4, and then, or that's 135 degrees. Now, just for the homework, just to kind of go over it, because there's no example here that we're going through, is that it's going to give you 2 points. So find, the inclination of a line that passes through the 2 points. And so just say, for example, 2, 3, and 0, 6. How do you find the slope of that line, right? We're just trying to find the slope. And so I hope you remember that you're just doing y2 minus y1 over x2 minus x1, just because, we haven't talked about it. And then, so you find the slope, and then after that, then you apply the formula. Hope this helps.